Thank you. Today we're going to talk about how Bankdata moved from the monolith Jakob built and to Micro Frontends, and how we did that in practice. So we are going to look at the architecture we chose and also some implementation details. So we're going to look at some code on how we actually did some of the more unique things related to Micro Frontends. Right. But first, just a bit about me. So my name is Rasmus. I have a master's degree in computer engineering from Aarhus University, and I've been doing front-end development for the last 10 years or so. And currently I'm a senior software developer at Bankdata on this platform team where we, among other things, build the Micro Frontend platform. Right. So to really understand why we are moving from the monolith to the Micro Frontends, we need to have some background understanding on what are we actually building and how are we doing it, and what challenges did we face when building it. So what are we building? Andre gave a great intro actually, but what we're building is an online and mobile banking application. We are building many applications from essentially one code base, one big code base. We have 3 channels, as we call them. So one application or collection of applications for the private customers, one for business customers, and one for bank advisors. So different user groups getting different features from the code. And we're also deploying this same code base to 3 platforms, so web and Android and iOS. And and all this we are actually building times 8, because we have these 8 banks who owns Bankdata, who all get their version of these apps with their own icons and their own colors and such. And even some banks get custom functionality as well. So some of the bigger ones, they even have their own developers who wants to build features for their version of the app. So we can do that as well, integrate custom features in some versions of the app. Right. That's what we're building. And how did we build it? So we use Angular for the front end, and we use NGRX for state management. And then we have all this stuff in one big mono repository, and we use NX to kind of manage all this. And then for the native apps, we use a capacitor, which is a runtime for taking a web application and building it into a native app, so we can put it in the app stores. So that's kind of the tech stack. And as an organization, we are organized in feature teams. So apparently 26 feature teams exactly. And each team owns the full stack of one feature. So there's an investment team who owns all the things related to investment, both in the back end and in the front end. Right. So what challenges did we face in this? So just for one, it's a huge code base, right? When 26 teams are just coding along, writing features, it's quickly going to be a big code base. And that's just, a big code base is hard to manage. That's just, And also over time, we started getting like slower builds and slower unit test runs. NX did help somewhat with this, because it can look at a change you've made and then only build and test the things that's been affected by your change. But over time, we got more coupling in the code base, so one feature started depending on another, and we have a lot of shared code also. So over time, if you make a change somewhere, you quickly affect a lot of stuff. So that kind of negates some of the benefits we got from NX. Also, we have in coordinating kind of cross-cutting things like upgrading the version of Angular. That's a difficult coordination task, because we have to have all these feature teams at the same time have their stuff upgraded to Angular 16. And yeah, so one team might have a deadline, so they can't do it right now, and yeah, so on. So these things usually took a long time. Then we have this kind of unique thing we call bank separation, which means that we have these 8 banks that we built for, and some of them build their own features. But one bank's developers are not allowed to see another bank's code or custom code. So we have to kind of be able to hide the code from different banks, at least until it has been released to the public. Yeah, and that's hard in a monolith repository where everybody has access to everything. Right. So Micro Frontends, let's talk about that and how and see how that could really help with these challenges. So for those who don't know what Micro Frontends are, it's not the most common thing to use. So I will try to explain what they are. And to do that, I took this from Martin Fowler, who kind of defines what Micro Frontends are. So he's saying Micro Frontends is an architectural style where independently deliverable front-end applications are composed into a greater whole. Yeah, it's a long thing, and let's kind of dive into this and see what he's saying here. So one thing he's saying is that we are composing front-end applications. So it's not just like a component or a module or a package that we're composing, it's entire applications that we are composing, which is quite unique for Micro Frontends. Also, they are independently deliverable, meaning that if I make a change in one Micro Frontend, I should be able to build that one Micro Frontend and deploy it. Then all the Micro Frontends can kind of get composed into the bigger application without having to build all those as well. And the last part is that it's an architecture. So you can't just npm install Micro Frontends and then you're doing Micro Frontends. It's an architecture, so it's a way of designing your application. And it's not even just an architecture that you can just read and then just go do. It's an architectural style, he says, which means that there are many ways to do it. So we're going to look at how exactly is Bankdata doing Micro Frontends. And I've tried to boil it down as much as I could into one small drawing, kind of to have something to look at and talk from. So we still have the monolith up there. We have these 3 blocks. The monolith still includes, let's say, half of the features we have. So over time we're migrating. It's not just one big bang of migrating. Some features might never end up in a Micro Frontend. And since we're organized in feature teams, one team who owns, for instance, the investment features can take all their features out of the monolith and put it in their own Micro Frontend. A Micro Frontend has its own Git repository, its own Angular application, and it's really isolated from the monolith. And that's a benefit we get, that it's just easier to work on a small application that you own than work on a big application that you share with a lot of people. So we get some productivity in the teams this way. And also, so now we have seen the big blocks there. There's different Micro Frontends, and they are isolated, right? So we sometimes also want to share things. So for instance, a Micro Frontend can share 2 kinds of things, what we call elements, which are custom elements, these native API in the browser for defining your own custom HTML elements. And the other thing you can share, if you want to share state or functionality instead of UI, you can share what we call APIs. And they are just Angular services that are kind of wrapped or hidden behind just a TypeScript interface. And the elements are Angular components hidden behind a custom element. And the idea there is to kind of hide that the Micro Frontend is actually running Angular. So that allows us to have one Micro Frontend running Angular 15 and one running Angular 16. So we can do gradual updates. So we can update the monolith to Angular 16 and then the micro frontends can do it at their own pace, when they're done with some deadline or whatnot. In principle, we could also write a micro frontend in React. We are not there, but in principle you could. Or if you want to migrate to another framework, you could do that. So now we have looked at we have the monolith. We have different smaller Angular applications which can share their services and components through these APIs and elements. So now let's look at how we actually implement this architecture. It's not just writing code. There's also a lot of tooling around kind of making a micro frontend platform. So one thing we have built is this SDK, we call it. It's a collection of all the code that is needed to run micro frontends. So downloading and bootstrapping a micro frontend, the whole thing about providing and requiring APIs and elements. All that stuff is in the SDK, which is an NPM package we publish internally in Bankdata. So every micro frontend Angular application uses that SDK. Then we also have a CLI so when you're building a front-end application, you're used to being able to, in your editor, just make a change and save, and it's going to update in the browser immediately. And we want to do the same, but now we are composing many applications, not just one. So what our CLI can do is start the Angular development server, starting up your micro frontend application, but also download a pre-built version of the monolith and make it load the micro frontend from the development server. So you can start up the monolith without having to build it, and then hot reload your micro frontend into it. That's one of the things the CLI does. We also provide some pipelines, CI/CD, for the feature teams, so they can focus on just building Angular features. And the pipeline will handle all the building and testing and linting and all that stuff. Also, we have to write some great documentation when we are just one team supporting 26 teams, so we can't sit face-to-face and help everyone all the time. So we have to have great documentation for them to be able to help themselves. And then lastly, we have this, we call it a developer portal. It's where, when the pipelines has built your micro frontend, the build is going to end up in the developer portal, loaded into the monolith. So you can go there in the portal and maybe download a version of the monolith running some feature branch of your micro frontend in an Android app. So all these different builds are contained in there, so you can go in there to test if you want. So that's kind of the tooling. So now let's look at what's inside a Bankdata micro frontend. So as I mentioned, it's just an Angular application as much as we possibly can. We want the developer experience to be just like writing Angular. The exception is that we expose these custom elements and APIs. So instead of normally you bootstrap one app component and then that's your application, instead you provide one or more elements or one or more APIs. We have this file we call a manifest. Think of it kind of like your package.json, but just for micro frontends. So it's a file in your repository laying right next to package.json, which specifies your micro frontend dependencies. So you specify the name of your micro frontend, and you specify all the APIs and elements that you require. Not which micro frontend comes from, but just that you need this API wherever it comes from. And you also specify what you provide, so which elements and which APIs you provide. All the manifests from all the micro frontends are downloaded when the monolith starts up, so it has the full picture of how or who provides what. And also a benefit from this, having this file, we have this static knowledge of who depends on who, so we can go look at all the repositories with a tool and see which team depends on who. So if one team exposes an API, we can see who uses your API. So if you want to make a breaking change, you know who to talk to. So that's the manifest. Let's look at how we actually expose these elements and APIs. And let's start with elements. As I said, it's just an Angular component that you expose as a custom element. And for that, we use this official package from Angular called Angular Elements, which it can take an Angular component and wrap it inside a custom element. And then you can, on this custom elements registry, which is it's just a thing on the window object. It's native in the browser. You define it as a custom HTML element. So you give it the name mf_sample, which is the HTML tag you define, and then you give it this element constructor from the Angular Elements package. And that's it. That's what you do to define an element. And as you see, it's in the app module of the Angular application. That's really the only place where we have exceptions from just doing a normal Angular application. So how do you use these elements? Well, since it's just an HTML element, you just add the tag somewhere, and then the Micro Frontend is loaded there. The exception is that we have this attribute, right? The Micro Frontend attribute, and what that does is trigger an Angular directive, which is just some code from our SDK that gets notified that now this element has been inserted. So it looks at the element name mf_sample and sees if this Micro Frontend has already been loaded. If not, it goes through all the manifests and see which Micro Frontend actually provides this element. And then it goes ahead and downloads and bootstraps this Micro Frontend, and then the Micro Frontend will be loaded. So here we also get lazy loading, right? So we don't load all the Micro Frontends on the initial load. We load it as soon as someone actually uses it. So that's elements. Just Angular components wrapped in custom elements. APIs. As I mentioned, it's just it's Angular services that we hide behind a TypeScript interface. So this is what you have to do to define a new API in your Micro Frontend. So you write this interface. It has one method, hello, and returns a promise. Nothing Angular specific. There it's just some simple interface. The other thing that you have to provide is what we call an API identifier. It's kind of like a dependency injection token. So it's a thing you can take and say, I have this token or identifier, and I want to provide this instance of the API for it. And when someone wants to use your API, they take the same identifier and go say, I have this identifier. I would like whatever instance of the API is provided for it. So yeah, that's that connection. Each Micro Frontend defines this two things, the interface and the API identifier, kind of in a separate NPM package. That allows the consumers of the API to go install that NPM package, and that way get the type safety and get access to that identifier. So each Micro Frontend exposes an NPM package with these two. And here you can see the SDK in action. So the API identifier is something included in the SDK. Right. So how did we register these API? So as I mentioned, it's you use the API identifier that you import from the NPM package, and you use this API registration service, again something from our SDK, and it has a register API method where you just give the API identifier and an instance of something that implements that interface, and that's it. And so So now we have registered this in one Micro Frontend application. But how does another Angular application running in the browser actually get access to that? How do we share that information between running applications in the browser? And that's actually pretty simple. Since we're in the same browser, we all have access to the same window object. So on there, we have an API registry on a property on the window object, and that's what that's where we go to register the API. So it's just that connection is saved in that registry. And in another Micro Frontend or in the Monolith, you can inject the API acquisition service again from the SDK. You import the API identifier from the npm package for the Micro Frontend, and you use that to get the API. And actually, you don't just get the API, you get a promise of the API. And why is that? Because, as I just said, the API is just registered on the window object, right? But again, here, we lazy load, so the service goes and checks on the window object and sees if the API is actually already there. And if not, it goes through the manifests, those JSON files, and figures out which Micro Frontend actually provides this API. And then it goes ahead, downloads that Micro Frontend, bootstraps it, and then that would trigger the registration in that Micro Frontend, and then it's available on the window object, and we can return it. So this might download and bootstrap an Angular application. So yeah, that's how you use elements and APIs. Okay, so let's look at the monolith then. We have looked at the Micro Frontend and how it's just an Angular application, and except we expose these elements and APIs. And in the monolith, the only thing we have added there is, for one, it's a list of all the included Micro Frontends. So again, kind of like the package.json file, you have this JSON file specifying all the Micro Frontends that are included in your version of your monolith. So you specify the name of the Micro Frontend and the specific version you want. For each commit on the master branch of a Micro Frontend, we build a version of that Micro Frontend. So each commit on master we can load into a Micro Frontend, into the monolith, sorry. Another thing the monolith does is provide some APIs. So, for instance, the authentication logic is still in the monolith, but Micro Frontends might want to know the name of the currently logged in user, or what is the selected language in the application, or environment stuff. And the monolith provides a range of APIs for those kind of shared state things. And also it uses custom elements, so that's how the general pattern that we use to load in Micro Frontends in the monolith. So usually each Micro Frontend exposes one element, like the investment Micro Frontend would expose an investment page element, and then in a route in the monolith, let's say /investment, we just load that one element, and that kind of the monolith then lets the investment Micro Frontend load or fill the entire page and show all the investment features there. So that's kind of the pattern we use. Each Micro Frontend has a route it's shown on. We could also, let's say, an investment Micro Frontend could expose just a component showing just your portfolio, so just the stocks and bonds you own, if you want to show that different places in the application. But so there's different options. So now we've talked about the monolith and the Micro Frontends and how all those are kind of connected. So how I've mentioned multiple times now, how do we that we just download a Micro Frontend and bootstrap it, and how do we do that? What we use for that is called module federation. So when you are building a front end, you're used to just writing imports in your application, importing all kinds of stuff from npm packages or just other code in your in your project, and then something just bundles all that stuff up, and it ends in the browser, right? And that's Webpack that does this. But as a default, all this code has to be there at build time. So if you want to import some code from an npm package, it has to be installed in your node modules. Or yeah, whatever code you import, it has to be available at build time, except if you use module federation, which is a feature in Webpack. And that allows you to use a dynamic import to import some module that's not available at build time. So you tell Webpack that this module will be available at runtime at this URL. And then Webpack just goes ahead and builds, and just at runtime, whenever someone uses this or tries to import this module, it goes ahead and looks at this URL. Could be a CDN or yeah, wherever. Yeah, it also allows so sharing dependencies. So each micro frontend that uses Angular 16, the same as the Monolith, we share that version of Angular 16. So for every micro frontend we download, we don't have to also download Angular 16 again. So we can tell Webpack to share some dependencies. But that's pretty much what I want to say about module federation. It's kind of a big topic, and yeah, there's a lot of great talks about that. And one of them has actually been at Aarhus.js earlier. So yeah, I've included a link for that. So let's look at some of the properties we got from this architecture. So for one, we can now build and test and deploy these separate features independently, which just decreases the build time a lot. We get smaller code bases, so each team just works on their own front-end application that they own completely. We have less coupling, or at least more explicit coupling, through all these elements and APIs. So you can't just import something from another feature without them explicitly exporting it. And that really makes, I think, some better coupling, because we are very aware of what we share. And when you make a breaking change, you are more aware because it's explicitly in your API or elements. We also get this gradual dependency up, where one micro frontend can run Angular 15, another 16. So that big coordination task we had, where we had to upgrade everything at once, we can now do that over time. Of course, that's also it could be a bad thing if people just then wait with upgrading, and you end up with 5 different versions of Angular in your application. That will, of course, affect performance. So it's a tool, but you should strive to of course, use the same versions of packages, because you're still in the same application. And then we achieve this bank separation, where each bank can now own a Git repository somewhere else in their own GitHub organization if they want, and build micro frontend features that gets loaded into their version of the app. And it's kind of broader than that, because it could also be, say we had some subcontractor that also wanted to build some features into the app. They can use a micro frontend to get that code loaded in without having access to all the other code in Bankdata. So we just perfectly isolated, right? We have separate applications, can run separate versions of Angular, and their own tests and all that stuff. But we're really not perfectly decoupled. There are still some subtle ways that we are still connected. So, and we can't really be explicit about. So it's not really a silver bullet in isolating teams. So for one, we are still running on one device, right? So we are sharing the same memory, and sharing, since it's JavaScript, we're sharing the one thread even. So if one micro frontend starts leaking memory or starts blocking the thread, then everyone is affected by that. And also we only have one network connection, so it might not make sense for every micro frontend to call the same backend for some information. But then you could combine that into an API. So there's that workaround. Also, we only have one global object, so one window object. And that means we share the same local storage, so you can, if you're not careful, override each other's local storage, cookies, and all that stuff. And even we have seen that some NPM packages that we use, they expect to only be initialized once. Maybe when one micro frontend initializes this package, and you give it some config, then it would save that configuration on the window object. And then when another micro frontend gets loaded and initializes this package, it would override the configuration from the last one. So not all packages that you use are kind of made for being used in micro frontends. So that's another thing you can run into. And maybe the most painful one I think is that you only have one URL, but we are composing applications, right? And usually an application does routing. So who owns the URL? And in our case, we have the monolith with a lot of features. It does some routing. On some routes, we load in a micro frontend. Then how do they share that URL? So in our case, we have said that we split the URL in two. So the first part is owned by the monolith. So let's say bank.com/investment is owned by the monolith. And as soon as that loads a micro frontend, then the micro frontend owns the rest of the URL. But still you have then query parameters, who owns those, and so there's not really a perfect solution for this. And what if you have two micro frontends who wants to do routing at the same time? You can't split the URL in three halves. So in our case, we just say that's not allowed. You can only have one micro frontend with routing at a time. I've also seen solutions where you allow the micro frontend, all the micro frontends you want to use routing at the same time, but the routing is not represented in the URL. But that then breaks deep linking, right? You can't deep link into one micro frontend. You just have to figure out a solution that works for your case, I guess. So, kind of to summarize, we started with a large project and many teams. Now we have even more teams and an even larger project. But we started out with more coupling, more implicit coupling that was hard to deal with. We had these coordination issues. It was a big task every time we wanted to upgrade some dependency, for example. So that means that we were usually behind on NPM package upgrades because it just took so long to actually upgrade. And then we had this thing with we needed banks to be able to have code in their own repositories that still gets included in the project. And then we started using micro frontends where we compose applications and they're almost perfectly isolated, but where they want to share stuff, they can share custom elements and APIs, which then hides that, it hides the implementation details of the micro frontend. So in principle, you could over time migrate to React if you wanted to. This really gives what I would call team autonomy. So each team now just owns one small Angular application in their own repository, and they're the only owner of it, instead of working in a big application that they share. So I think a lot of productivity is gained from that. And I think that's really maybe the most important value we get from micro frontends is that, it doesn't really solve many technical problems. It doesn't do any good for performance because you're running many applications. And it's just more complex than than having one big application. But it really allows each team to be more productive. So it scales well with adding more teams. Yeah. And I think that's what I have about how we migrate from a monolith to Micro Frontends. If you want to learn more, because there's a lot of things I had to skip over to fit it into one presentation, I think here are some good resources. As I mentioned, Micro Frontends is not just an NPM package you can just install, but there is that one NPM package you can actually just install, and you're not doing Micro Frontends, but you get a really great start, I would say. And then there's this guy, Manfred Steyer, an Austrian guy, I think. He's just he's the guy when you talk Micro Frontends in Angular. He has done a lot of great talks and blogs and a lot of resources about Micro Frontends. Or if you want, you can contact me, because as I said, there's a lot of things I didn't have time to say. So I would love to talk more about Micro Frontends. You can download the slides. Thank you.
Wow, thank you so much, Rasmus. I think actually we have 5 minutes for questions if anyone already has some. Here we go.
I'm curious if you have any issues with circular dependencies between Micro Frontends, if you have one feature depending on another feature, and vice versa.
So Rasmus, maybe you can repeat the question, because then we get on
Right,
the recording as well.
So the question was about if we have issues with circular dependencies between Micro Frontends. No, not really, I would say. Since, and I'm not 100% certain, but since we are loading Micro Frontends only when, if they're not loaded already, so when one Micro Frontend requires another, it can be done so lazily, and if it's already there, it's just already there. So I don't think we have issues with that. You can, however, I didn't mention that, but in this manifest where you specify that you require an API, you can say that you want it equally, so it's not lazy loaded. So it's loaded as soon as your own Micro Frontend is loaded. And if both equally require each other, I guess there's an issue there. I hope that answers. Maybe.
We have 10 minutes for questions.
Have you measured any changes to performance from the monolith state to the micro?
No, we don't have any numbers, but I just assume at least. Sorry, I forgot to repeat the question. So the question was if we have measured any performance degradation after using Micro Frontends, and no, we don't. We haven't measured it, but I just assume, since we are running many potentially with different versions of Angular, it will have a performance hit. Of course, maybe the Micro Frontends are then optimized better, and they can do change detection only in that part of the application and stuff like that. So it's complicated to just say. So you will have to measure, but we haven't.
Could you maybe add a little bit on how we resolve, like if Micro Frontend needs a certain dependency, that if they're within the same major version, we actually resolve it to the same?
Oh yeah. So so what if one Micro Frontend depends on Angular 16 and one on Angular 16.0.1? Then using module federation, when we share dependencies, we can specify how specific we want a package. So we can say that we just want Angular 16, and then we can, by sharing, Webpack can kind of resolve who wants the latest or who provides the latest version of Angular that most Micro Frontends want, and then it's kind of smart about loading that.
Yeah, that's you. Yes.
How big are your Micro Frontends? Like, how many Micro Frontends would normally be composed into what
Yeah, that's a good question. So the question was, how big is a micro frontend? And yeah, that's the question. I think it depends. So I would like that just each team just had one micro frontend, because there is an overhead and there's not much benefit in one team having many micro frontends composing. Unless you have one micro frontend used in one application and another in another application, you get a bigger bundle if you migrate or merge those, but only use half. But in general, you shouldn't just have like one button and that's a micro frontend, because there's a lot of overhead. So yeah, as I would say, as large as the team feature is, basically, yeah.
Yeah, if it's me now. Yes, it's you.
Okay. I was wondering, so you're using this for mobile, right? I think at least on iOS there's a requirement that you need to bundle everything upfront when you submit it for review.
Yeah.
So you talk about lazy loading and modular federation, so I'm just thinking, how does that fit into bundling everything?
Yeah, good question. So yeah, the question was, how do we in an app where you're not allowed to load code remotely and get accepted into the App Store. So how do we deal with that in the apps compared to on the web? And in the apps, we actually, when we build a version of the app, we download all the versions required for, or the micro frontend versions required for that app, and bundles it inside the app. So from the Monolith's perspective, it's asking at some URL, but it's really just getting pointed to a file that's already in the app. So in the app, it doesn't go over the network. Yeah.
So does that mean that part of the app, that particular micro frontend, is lazy loaded or lazy instantiated, but the code is already there? Is that what you're saying?
Yeah. So it's lazy loaded in the sense that it's not being passed or imported into the browser before someone actually imports it, compared to the web, where we actually also first download it when you need it. So yeah, that also means that on an app you have to worry a bit less about bundle size, but on web you have to worry more about bundle size, because when you enter some route, you have to load the entire micro frontend over the network. Yeah.
Maybe one last question. Terry?
I'm really interesting talk, and I was thinking about, you have many different product teams owning different frontends and micro frontends, and they're all composing to a global app. My question is that, how do you enforce some kind of team culture? You know, when you share, like, let's say you talk about route hacking, where you kind of multiple frontends pointing to the same route, and also the shared global object. So how do you communicate this or enforce these rules across multiple product teams?
Yeah, great question. Yeah, so the question was, how do you coordinate all these teams on kind of culture-related things, like how you do things the same way across teams, I guess. Yeah. One thing is just documentation. As I mentioned, we do a lot in documentation, and another thing is, if you try to instantiate your micro frontend when there's another one loaded, you just get an error. So they won't really get far when they try to develop that feature. Yeah, since we have this SDK and we have pipelines that generates a template for a new micro frontend, we have a lot of control there, you could say. So we can put in like custom lint rules that we want to have enforced across, and stuff like that. And the CLI we have built has an update command. So even though you might have built your micro frontend from an old template, you have this update command in the CLI, which can take you up to the latest version of all the NPM packages you share with the Monolith. And also there we update the pipelines and other files in the micro frontend project. So we get some control there. Yeah, good question.
Do you use anything for the UI to make it consistent?
Yeah, so Jakob is the lead developer in a design system we built at Bankdata, and yeah, so that's also one thing you might want to share. You don't want each micro frontend looking completely different from each other. So yeah, we have a great team building a design system that we use across the entire app. And also there's a thing about being behind on dependency versions. So let's say one micro frontend is 3 versions behind on the design system. It's going to look different maybe from all the other features. So that's again one place where we are kind of not isolated. Or yeah. Yeah.
Thank you. That was a really high to end on. Sorry. It could also be a component library in the design system. It could also be Angular material design, but align on something that makes it look consistent. Thank you so much, Rasmus.